All right. I believe we can begin, and as people will join the presentation, it's open to join. So yeah. So basically, this particular webinar, as you already know, is dedicated specifically for the update 3.9. And we'll go through basically all the features that we have added, all the major features, let's say, that we added into the new software. Right. So first of all, it's not really about software, but more about the activation. We have finally added the web activation. Now we have a lot of forensic clients and also people who have offline computers, who use offline computers for the dump reconstruction and so on. So it used to be like kind of inconvenient through email. You had to send the activation file and then you wait for sometimes 15 minutes, sometimes shorter or longer. Now we actually, as you can see on the screen, we actually added the web activation method, which you can use when you basically run software. You will see the window that will ask you to enter this typical information about username, company mail, and so on. And then you can choose offline activation, save a request file, and you should log into your client portal, which you can find on RecuperoDatos.com in the support section of the website. So once you log in into the client portal, you can just simply hit this button, the software activation button, and upload the file and basically wait for like up to 1 minute normally, no more. And you can download the offline activation file. So without any human interaction or waiting from us to get a mail back. So, and basically everyone can use this feature, not only not only users with the active support subscription, as well as pretty much any users who have who doesn't have a support subscription can also use this particular option. It's available in all client portals pages for everyone, basically. Right. So we hope it'll make it final, because we had several, like a lot of times actually, not just several. We had a lot of times requests from our users, like they sort of like fed up waiting, sometimes, especially because of time shifts. In many cases, we did this activation manually. Now it's all automated. Finally, no hassle, no waiting, and you can just click a couple of buttons and get it very fast and efficient. All right, so that's a really simple feature. I don't think, I don't think I have to explain here a lot. It's a self-speaking feature. So let's move on to one of the really interesting and technicalities or technical features that we have added. So I will go from the really sort of like simple features and from smaller to the bigger, and then at the end we will do together, and you can try yourself on your computers, the bed column removal, which is obviously the most interesting feature in this, but one of the most interesting features in this update. However, let's begin with a file system corruption analysis feature. For a while, we have this button, we have this function in the software, but as I know, not many of you used it. It wasn't, I think, very convenient in usage. There was a bit of lack of some information about file location according to the block address, basically block address of file, as well as state of file, whether it's corrupted or not. So as you can see on the picture here in the presentation, we quite significantly, basically we added a couple of simple things, but they really simplified life a lot and basically made this particular mode very efficient now. And I mean now pretty much all of us use it for the cases where you have file system corruption, because in case of file system corruption, sometimes you don't really know what exactly had happened to the file system, whether it was the real logical corruption, or whether it was bit errors, or maybe it was just simply wrong blocks put into the table, and then because of some shifts or offsets, you got all file system, shifted or eventually corrupted. So this. Let's open up the visual line reconstructor. We have prepared special cases which will demonstrate this option. Basically, obviously, you can use on any, in every single case. It doesn't matter which file system you have. This works for pretty much all of file systems, including Mac and others. So this particular analysis is based, solely on the header and the file location analysis. So I have opened the case here. It doesn't really matter what kind of controller, what kind of transformations we applied here. It's not really important for this particular mode. So the file system corruption analysis you can open only from file system viewer. Obviously, that's where you want to check file system viewer. And so in order to get file system, first of all, as you probably know from the previous webinars, you have to remove basically all transformations, all sort of ECC, inversion, scrambling, and so audio is missing. Okay, I think you should turn on your speaker probably. So, anyways, so basically you remove all of the steps up to the mark stable and up to block translation and eventual logical image. So here I have prepared case. We're not going to dig into the steps and so on for now. So what I did, I have just created logical image. Now I have here the assembled logical image, well, supposedly well assembled logical image, and so we can open it in a file system viewer. Well, you can see it looks all right. I mean, you get a structure until you actually open up the root folder, where you can clearly see a lot of things. Really, it's looking really bad. So, as you may guess, there might be, well, I wouldn't say billions, but a lot of reasons, right? One of them might be the real corruption of file system. Another one, but that's less likely, because I mean normally if you get hardware corrupted devices which are subject to chip off, you'll probably get more or less an intact file system. There are some cases, however, where file system is also corrupted. So, anyways, another type of problem could be bit errors, as you probably know from the previous webinars, especially with the newest devices, TLC chips. You always have to reread chip multiple times through ECC, through the maps, through read try, and sometimes playing with voltage or some other approaches. So that's the second cause of the problem, which is the bit errors. And last but not least is basically conflicts or the problems in the block translation. So if something wrong in mark stable or in translation of blocks, you will certainly get some files or even half of file system corrupted. So basically, and this is a really simple feature, that no-brainer, that allows to find if there is some problem, particularly with block assembly or with the file system assembly. So let's see how it works. So here we have this window. For now, in this particular version of software, you have to specify block size manually still. I think we will make it more automated in upcoming update, hopefully. So here, the block size. But in the file system level, basically you're working with data. There's no blocks now, right? There's data. So, but you still have to set the block size because you want to understand to which block this particular file belongs to, right? So how to find the block of data or block size on the file system level, let's say. So it's a fairly simple job because you built a logical image from here, right? From the you build it from Unite. And basically, hold on. So here you have the you can see the comment here. Basically, you should take block size from the source, from the unite, from the source of logical image, from the last step of conversion of the dump into file system. So on unite, we can see here the parameters which we need: page size and block size. Right? So here we have block size in bytes, and that's what we need. However, because we cut off SA and ECC here on logical image, we actually have to specify just the size of data, size of block of data, right? So here's calculation. It's fairly straightforward, I hope. So here we had a block size of page size initially was 2 kilobytes. That's really simple old case, 2 kilobytes. Which means data area was 2048 or 2048 bytes. And we had 128 pages here. So here's the math. You can see page size, which is data area only, was 2048. Block size 128 pages. And then you just do multiplication of page size and the amount of pages in block, and you get your value, which is around 260 and something bytes. So that's the data size. Pop-up window. That's the data size of the block without SA and ECC. And that's what you should specify here. System. I'm just going to copy paste this one. Here, okay. It takes a bit of time to analyze file system, depending on how many files you actually have. Could be like 20-30 seconds, and I believe up to 2-3 minutes, sometimes more, especially if you have a device which is full of documents or some sort of tens of thousands of files, or maybe even hundreds of thousands of files, small files. So that'll certainly take more time on the larger amount of files. But this particular case, with a very funny file names, horse lease agreement, whatever it is, it'll take just probably half minute or maybe 1 minute to go. And then eventually you will get a table with files and relative offsets and file condition. As you can see, the progress here basically showing the file which is now being analyzed. It also shows the amount of errors in file system. So far, it is around 44. It's not too many, but that's something. So here, basically, all the files now they are sorted by by physical location. But basically, they sorted by to which block they belong to. Right. So here you see one of the very first files, which is located in block number 1. Then you have another one, block 4, block 7, block A. So here, obviously, numbers in hexadecimal. So yeah, basically, what I do here is just simple visual check, and as you go further, as you scroll down, you can actually see there's problematic files begin. So the red files here. So that's, I mean, you can see the header here on the left side, which is obviously green is good, red is bad. You can see the physical block where this particular file is located. You can see relative offset from the expected position of file. That's not, well, could be it could be useful, but in our personal experience is not very much useful, because there's exact reason of why the files are shifted. And it's a rarely some sort of metadata corruption or stuff like that. It is in many cases it is related to to the blocks, basically to the problem inside the marks table. So from here we can actually see, just a quick check, 5-second check, and you can find the place where problem begins. So that's basically important step. You should figure out where you get the first problem. Right over here, as you can see, this is block number 98. So this is block number 98 from the beginning of the marks table, from the very top. It's it doesn't have to be the specific block, specific block with the LBN number 98, because if you have multiple banks, you can have, this block slightly shifted in another bank, and then, it's basically physical position of block in marks table. So now, in order to understand what actually happened, we can go back to marks table, because that's what you do a lot when you purifying a logical image after initial assembly. Normally, you'll go back to marks table and try to find the problem and fix it up. Right. So here we have marks table. Double click. You can open it up. And here you can spot we had a problem in the area around block 97, 98, so around this particular area. So you can scroll down here, and you can see here at the bottom of the toolbar, the status bar of the window, you can see the physical position of block, and here you can see the logical LBN, logical block address. So you should rely on this position, because if you have multiple banks and your file actually belongs to another bank, which is shifted, there's going to be another LBN there. So now I'm just going to find the block number 97 or 98, which you can easily do, of course, by search here, or you can just scroll down and find it just manually. So yeah, and you can see, we can certainly see here the problem, which for many of you is probably obvious, especially if you followed our previous webinars about marks table. You can clearly see here the duplicated, duplicated blocks, basically. Right, and then in many scenarios, as you can see here specifically, those blocks have same LBN number and as well as same header, and sometimes they have pretty much all SA same, the whole per area, right? So, and in some cases, maybe not many, but in some cases it's just a game of guess. You gotta guess which block was latest, and you have to use that particular block in your file system. But now, in conjunction with file system error analysis, you can actually do quite a smart thing. I mean, you can basically adjust your logical image, and because you know exact place where this file is located now, right? It's in block number 98, around 98, 97, right? So now you can basically, if you usually you don't have like thousands of blocks duplicated, right? It's normally, I don't know, 5 to 10 blocks, sometimes more, sometimes less, right? And it doesn't take too much time. We're thinking about further optimization, obviously, but that's for now. That's what we did. And you can you can choose the block sort of like smart way. Well, let's just give it a try to the first one, right? First block. And obviously you have to rebuild a logical image now. And go back to, because these results are not really actual anymore, because you refreshed everything. You refreshed the marks table, rebuilt logical image, and so on. So it'll probably get better now. Yeah, you can clearly see it's almost 100% clear. Maybe not exactly, because you don't know what's going on in folders and subfolders and so on, because there might be some multi-level folders, and there will be some corrupted files. Right, so we want to try this again to run file system analysis. and see what we're getting now. Now it's working fast, obviously, because we already, you know, we keep some of the data in the memory, in the RAM memory. All right, so you can clearly see now pretty much everything is green here. So at least this doesn't really mean that, you know, every single file is, you know, 100% correct, because this does not check with errors, right? This doesn't check ECC. So that's just to keep in mind. It only checks headers, right? So file location, basically. Anyway, just out of you know, out of interest, out of curiosity, let's just pick up another block, right? This one, 97. Let's go back to marks table, rebuild again. Then we need to run this file system analysis or check file system option once again. Hopefully it'll do fast now. All right, and yeah, you can see most of the stuff here clean. There's one particular file which is located in a particular block became red, right? So here's the one: selection criteria, blah blah blah. Right, so this particular file is located in block 97. So that's exactly the place we've been, you know, block we've been playing with. Right, so from here we can sort of like smart away. We can choose you know, proper block out of 2 or out of 3 if you have. Guys, if you have any questions, I think we're not gonna like stop. Basically, for now, it's you know, sort of like we're going through the features, and then at the end of the webinar, I'll go through all the questions you have. We'll, you know, scroll down chat. So please try to keep questions really like, you know, compressed in one message, like Leo did, for instance. Yeah, we'll get to it. All right. So that's pretty much how it works. And there's one quick question: what does flag mean? So there's flags actually. They actually mean basically it's a simple, you know, header check, right? Every single file has well, not every file except TXT files probably, and some others. Most of the files, they have headers. So it's so-called magic numbers or headers, or, you know, beginning bytes of the file. And we have the reference which links header with the file extension. And this way, I mean, it's a fairly simple algorithm used pretty much in any data recovery software. So it's a very simple, you know, like header check. You can also find plenty of information on Wikipedia about the, you know, headers and magic numbers of you know, hex headers of the files. Right. So that's basically all, you know, all the usage. Well, as you can see, obviously this can help a lot if you looking for specific files, for instance, or, you know, particular and you particularly have like multiple blocks duplicated and you don't know which one to choose. And here you can actually do it, you know, smart way, not just, you know, random guess. Or it can also help a lot in many cases, just to, you know, just to figure out where your problems actually begin, from which, you know, from which block problems start. All right, so that's really quick review of the feature. If you have any questions, just you know, throw them to the chat, and we'll go through it and reply at the end of the webinar. All right. Let me share. So let's go further to the next options, next features we added. All right. So here's the like little tiny but very useful features we also added into this update, which we released just 1.5 months from the previous update. So one of those is going to be BCH, or new ECC codes, new ECC families. So as you know, controller manufacturers, they never really get tired of inventing new things and optimizing data recording process and data recording, data reading process. So they still can use this for quality chips and so on. So basically every year they change something, and every year, 1.5 years, they change a little bit of ECC codes, they change scramblers, they change a lot of these tiny things. And obviously that makes our life a bit harder, and yours as well. So and one of these changes was like a half year ago or something. It was specific SM controllers or circuit motion controllers. They began to use slightly different ECC codes. It's still BCH codes, so it's not something like LDPC or its home. It is still BCH codes for those particular controllers. And now we figured out, it took us a bit of time, but we finally figured out what was wrong, what they changed basically, right? And they did change some very precise, very particular feature of ECC engine, which was bit rotation. We just haven't seen this one before, and now we added all of them, all possible combinations. And this particular feature was added into BCH, into BCH codeword analyzer. That's our quite unique tool for brute force and BCH codes on pretty much any devices. And let's open the case, and I'll show you how it works and how you can use it. We got a physical image from one of SM controllers. It doesn't really matter from which particular one. It's one of the newish ones, because sometimes you don't even know which particular controller model it is when it comes to micro SD cards, when it comes to SD cards, and this sort of monolithic devices. So you never know what controllers they use until you decapsulate a chip or something. So anyways, so here we got a physical image, and it's got a pretty unusual page structure, by the way, for this particularly newish SM controllers. It's just 512 bytes of data, and then quite a huge amount of ECC code, quite a well protected data areas. As you can see, redundancy here is probably around I'd say like 20%. Yeah, how to use this new codeword analyzer feature. First of all, we got a lot of questions from previous webinar, how to find the ECC code, if it's unknown and so on. So this particular demonstration now will show you quite quick, but I'll show you how to deal with unknown ECC code. So in order to find the unknown ECC code or of pretty much any controller, if it's a BCH code, you need to, first of all, you have to figure out page structure, right? We have quite a long webinar, thanks to Igor, and I think it's a very good one, about page structure analysis, about a lot of things now. We have now a lot of webinars, and most of the subjects is covered there. So if you don't know how to find page structure, you should definitely go to our YouTube channel and find these webinars, because each webinar is recorded. So you can find each webinar, and you can find the one with the page structure analysis and just go through it yourself in order to understand how to do that. So for now, we just take it as granted. We already got page structure, so now let's work with what we got. Right, so I kind of use a lot, and I like a lot of these features that we have in the Visual Learning Constructor, that you can actually split windows. It's very useful. Right click, split windows. So now at the left side, I can see the ECC, the page structure. I can see the data areas as well as ECC here. And this controller has quite specific page structure. Well, it's very similar to other silicon motion, but just data area size is a little bit strange for scrambled device. So anyways, so here we have page structure, and now we want to find the ECC code for this particular controller. So in this update, we actually, besides all the new features, which you've probably seen on the website, we have also added quite a few new ECC codes, new scramblers, new pinouts, memory chip configurations, and so on. And one of the ECC codes we added specifically for those newish Silicon Motion controllers. So now if you run in latest update and if you just click find code words, it will be it will find you the new code words and the new ECC code for this particular controller, right? But if you get some the similar controller with a same problem that you couldn't find automatically ECC code, you can always build your own. So here you just need to attach empty ECC element here to the workspace, but make sure you got already page structure assigned, right? So you can click code word analysis button here, code word analysis. Right, and from this point, you need to describe basically payload and parity, because every single code word and one page consists of multiple code words. And by code word, we mean essentially payload plus parity. In Silicon Motion controllers, in most of the cases, payload consists of data purely. And for instance, Phison or SanDisk controllers, the payload actually equals to SA plus data or data plus SA. So it all depends on specific controller, because spare area is usually protected as well as data, obviously, right? So so here we have the payload and parity, right? So we need to basically, when you're looking for parameters of ECC code, you're not really looking into parameters of every single code word, because, well, all of them are going to be same, just as the first one. So at least maybe not sizes, not offsets, but I mean the particular parameter is going to be same, such as a polynomial and these operations and so on. Right. So normally we do analyze the first code word, but you can do, if you like, you can try a second one or third one. It doesn't really matter. You just need to precisely specify here the beginning and end of area, or maybe not very precisely, by the way. So here we have payload. So in this case, we have 512 bytes of payload, and then we got 92 bytes of parity. Right, so here we basically say our payload begins from 0, from the very beginning of page, thanks to very simple page structure of SM controllers. Last byte. So the last byte basically it begins from 0, and the last byte of payload is 512. Sorry, 511. Yeah, that's important because we begin from 0, right? Even though size is 512, but we start from 0, so we should keep it in mind. So the last byte would be 511, but not 512. So basically, you can just repeat here the structure. You can just take structure from here on the page, 0 to 511, and then 512 to 603. 603. And that's pretty much the formula or the structure of the page or structure of code word, right? It's got some additional parameters which are not really, explainable simple way, because these are very specific mathematical, parameters. But luckily we can brute force them. So here, as you can see, it's simply the beginning and end of every area in your page. And here's one interesting thing. As you can see, basically, as you can see, we have every byte doubled here. Like, the question is why? Well, simply because this brute force analyzer, this code word analyzer, which we made, sometimes we had cases where we're not really sure where data actually ends and where parity begins. So we were sure like plus minus 1 byte, plus minus 2 bytes. So, but we didn't really know. And so we made it the way that it's kind of like a floating logics. Basically, you can start from specific offset, but you can end on, this byte or next byte or maybe next byte. So it's like, plus minus 1 byte or plus minus 2 bytes. So let's say if you're not sure here where's your end of ECC, you can say, okay, look for 511, 513, and then you can adjust parity the same way. But anyways, we will do a webinar, and I think we'll show this, quite detailed explanation of the this BCH codeword analyzer as a separate webinar, because as you can imagine, it's not a 100% easy and straightforward sometimes. But yeah, that's basically parameters you have to specify, and about the rest you don't have to bother, because now we made basically all possible combinations that controllers use in terms of BCH code structures. So here we analyze typical polynomials. These are most commonly used. You can, if you like to check this, these are basically default parameters. And I would always recommend you to start from this exact default parameters, because in majority of cases this would work. So if you couldn't find automatically ECC in database, you still can quite easily in many cases find parameters of BCH using this brute force tool, which is quite unique. So let's just try with the default settings. Let's see what we get, and we get nothing. So here's just empty, nothing, no candidates or anything, and that shows you basically nothing is found. So here you have additional parameters. Most likely, well, it could be, first of all, it could be because you didn't choose like all of those polynomials. But just to speed it up, I'm not going to choose them now because it'll take more time. Or most likely because of this. Right? As you see here, we kind of skip a lot of this combinations of these operations here. So what we can do is we can choose all of those. And in let's say in the real case scenario, you'd probably go, you better go to, for all of those polynomials as well. But now just to speed it up, just going to skip it. Yeah, this also takes some time. Depends, obviously, this depends on computer performance as well as on the size of code and all the parameters that you specified. As you can see, nothing is found because I accidentally unchecked this one. That's exactly the polynomial we need. Right, so let's run it again. Now we got a hit here. As you see, that's quite a very probable result, which is weight. It's sort of like related weight, relative weight or probability of the specific code word parameters. Here's the short formula. As you can see, that's your payload, it's your parity position, its positions, decoder parameters, which is a 512, 92. It's again, this is data, payload, parity sizes, and some additional parameters. But from here, you don't have to bother much about adjustments anymore. You can just click add code word, add first code word to your ECC code, and that's what you get. So you already got it here. So this code word analyzer we don't use for full code structure analysis, but we should only use it for one particular code word analysis. All right. So from here, of course, you can expand this code according to your page structure. But that's I'm not going to do it now. It's a subject for another webinar. So how to make sure your code actually works? It's fairly simple. You should hit the ECC map button, and that will show you the if map is green, you see the legend here, legend of map. The dark green means no error, light green is correctable errors. This information we have, I think, in article as well as documentation. So yeah, here you have majority of pages green. Obviously, there's one, as you can see, one red page here. It's a not rare situation with current memory chips. In many cases, you have to read them multiple times. So this dump has never been touched. It's just one read straight from memory chip, and that's it. So here it looks pretty good, as you see. And as you keep adding code words, we will actually show you here one square. Will show you the average, not really average, but the worst out of code words. But I think on the later webinars we'll probably stick to the subject and explain it in the great details. Right. So for now, yeah, this code word analysis now allows you to analyze newish BCH codes of silicon motion controllers, and I believe others may utilize such options as well. Some no-name devices where you don't know which controller is. Right. So that's pretty much all about the BCH, this new BCH feature. Now there's a couple of really useful, small but very useful changes we did. As you can see, I hope you can see the screen here. So yeah, now you can adjust XOR element. You can adjust it to any area, because it used to be like you can only adjust it to data area, but now more and more, as we see, newer devices, they utilize scramblers, utilize XOR for spare area as well, and some of devices even scramble ECC code, ECC area as well as SA. Right. So I would say for most of them, we have now scramblers, and we have XOR keys, so we can successfully, not in 100% of cases obviously, but in majority of cases we can successfully descramble SA as well as ECC areas. Right. So that's a small feature but quite useful one. Let me quickly show you how it works. So here, I'm just going to show it right here, the same case. Basically, now when you connect the XOR element, if you want to, unXOR your dump, you would probably go for XOR analyzer, which is also quite a new tool we released in previous updates. And you can pick up the XOR automatically from XOR analyzer if it's supported. Or if you develop your own XOR key, for instance, you're probably going to go manual way. And from here, from the settings of XOR, you can adjust it now to pretty much any area. And you can, if you like, you can separately DXOR like data, and then use another XOR element to DXOR SA, and then third XOR element to DXOR just ECC, if you like to. So let me just demonstrate it real quick. How this works. I'm just going to pick up random key completely. It doesn't really matter which one. That's just about option now. And so here, when you click the adjust key, in many cases it's adjusted automatically, obviously. But if you want to adjust it specifically to some particular area, you click here, XOR key adjustment, adjust key. And by default, it will be auto. And auto means it's data. So we adjust key to data area. But if you like, you can now select here pretty much any structure which you specified in the page layout. It could be ECC, SA, or like whatever you might want to apply XOR to. Right. So that's a quick small feature, but that helps a lot sometimes to save a lot of time. Right. So let's move on, and let's see what else we got in the 3.9 update of Visual NAND Reconstructor. So yeah, there's another one that's a real quick one, but we got several requests, probably more than several requests from our users, and we do listen to users. We find out the feature to like a complete page structure, more like an automatical way. Now, in many cases, when you find ECC, of course, will complete or almost complete your page structure automatically. But if you do manual page analysis, for instance, if controller is new or unsupported or anything, you're probably going to do it manually. You're probably going to manually find and assign a data area, ECC, and so on. And so, if your structure is periodical, or it repeats some particular it repeats multiple times with the same sizes and everything, So you don't have to copy and paste it till the end now. You can simply, hit the paste to the end button and get it. You get it, the whole page layout completed. It's a really, small, tiny feature, but it's I think, very useful for a daily job. It does simplify a lot. So here is, let me just quickly show you how it works. It's fairly, simple and straightforward, but let's just see. Let me just remove some of those structures here. Now with the press shift and the keyboard, I can basically select all of the structures, remove them. Now I want to copy those two, right? And well, I can do paste, so it'll paste just one, basically one time or one chunk, or you can just hit the paste till the end, and it will do it right till the end of the page, till the end of the unaddressed area, up to the next addressed area, such as SA in this example. So yeah, that's really simple thing. Right, so let's move on and let's see what else we got. The further we go, then the more interesting features get in. Yeah, so that's quite a big one. It's a big change. File Carver. I hope most of you already have some experience. Our File Carver now. I mean, obviously, as you know, there are solutions in the market. There are other solutions, several very good softwares for the file carving, for file recovery from the raw dump or corrupt file system. But we go our own way. We want to sort of connect the file carving, adapted to the problems of the memory chips, let's say, because memory chips have a lot of problems, bit errors and a lot of stuff. And so our file carver now, became even more powerful. First of all, we completely revamped the interface because it was not really user-friendly, probably, but now it's just, in my opinion, it's just beautiful. We probably have a couple of tweaks and things to adjust, but yeah, now it became really human-friendly, right? So yeah, so let's just have a quick look first at the interface, and then we'll go through new features which are also very important, which we added. Let me open up the case which I specifically prepare for the file cover. One second. So yeah, as you can see, basically here, 4 things that we have changed in File Carver. The first one is just completely new interface and much more convenient workflow, much more convenient file analysis, because that's what you want to do in many cases. You not just want to just get all the files, but you want to split them into categories. You want to analyze them precisely and so on. Right. So now you can do that. Also, we have finally added doc and XLS office analysis. Yeah, let me open the case. Sorry. Yeah, I hope you can see now. Right. So here we first of all, optimized interface. We added doc and XLS support. We should still see a lot of people using this doc and sort of like oldish. It's a Word 97, I believe, file format. I'm using it myself sometimes because of compatibility, and it's in a lot of cases we you need to recover documents and this XLS files, specifically previous formats. And of course, if you compare those docs and XLS to docx and XLSX and this X family of the Office, they are just 2 completely different universes. Docx files, they're based on zip archives, and these doc and XLS files, they are just completely different file formats. So it did yeah, we can also check integrity of those files. Obviously, we not just added carbon, but we can quite precisely check whether the file is good or bad. Right. I'm going to show it in a while. So also new, very useful feature sometimes. Honestly, probably not for all cases, but especially if it's forensic case, you definitely want to see EXIF metadata for the carved JPEG picture. So now we can show you the the camera model and stuff like that from the JPEG files. And one of the really good features which you, I hope, will love is ability to reread memory chip through ECC map. Well, through two maps actually, right? Through ECC and through file map, but not just the file system, because we have the option to ECC, reread ECC just for the whole chip. We also have option to read ECC, as you can watch this in our previous webinar, which Igor did. You can read the ECC, you can read blocks through ECC, you can read files through ECC, but we didn't have option to read. You had only option to read files which you can see in file system through ECC. But now we connected ECC read to carved files. So now basically you can read the ECC anywhere you want. You can read memory chip through ECC. And yeah, that's a very useful feature, because sometimes you know exactly what you're looking for, but in some cases you don't have file system. That's reality of data recovery. But you know for sure, for instance, you want some particular, and we had, like, in our support department, I tell you, we had tons of those cases where people had a trouble opening file system, and they knew they needed particular files, they needed particular specific pictures, but they were corrupted. Right? It could be whatever. It could be wedding. It could be it could be forensics. Some sort of criminal. Some sort of very different types of pictures. And from time to time, you see, the tiny slices, small artifacts on these pictures, which are caused by bit errors, right? So now you can read them and, purify these files, which are carved through multiple memory chip reread, obviously with the retry, with, all standard features that we have. So now let's jump into the real case. I'm going to show you all of those features now. Assume that you don't have any access to file, file system. You just, build whether blocks are still mixed or not, or you've been able to assemble them somehow, and you want to run a File Carver. Well, normally we use File Carver, and our users do for two purposes, right? First one is when you have the real corruption of file system, and you couldn't fix it, or maybe you couldn't, assemble blocks into file system, so you're going to use Carver for sure. The second thing is just to, sort of like an evaluation or estimation of how good or how bad your assembly is, because not really always, not always you can tell by file system whether everything is perfectly fine or not. However, I would say, for instance, when it comes to bit errors, when it comes to XOR keys, when it comes to pretty much any problems, the best indicator, the really best one for how good or bad your dump is JPEG file, as you probably know. Right? If you can find JPEG file, that's just like a golden rule in the chip of data recovery forensics. If you can find large enough JPEG file, well, say 1 megabyte, 2 megabytes, and the file is good, so you can open the file and there's no artifacts or bit errors, you can tell for sure that you're definitely on the right track and you are very close to getting logical image, quite a clean one, right? But if you get like thousands of JPEG files, all of them corrupted, there's probably some sort of issue, most likely bit errors or something like that, right? So let's open up this new file system viewer, new File Carver. And yeah, as you can see, here's completely new interface, which is obviously we try to adjust it to existing file system viewer, so all our users don't get completely confused when they got to the new interface. Right, so there's really not so many buttons here. We keep it really simple. Just run search, right? And you can see now we kind of nicely sorted, not only by file type, but also by you know, by how good or bad file is. That was also I apologize. It was added in the previous update as well, but now it's just more, you know, more ordered and sort of organized, much better organized. Right, so I do believe it's probably enough just for the quick look. So yeah, as you can see, we found some JPEG files, and as you can see, we quite precisely split them into categories. We split them into, you know, good files, which you can also browse here as a, you know, thumbnail. Let's get some large one. This one. All right, so yeah, so you can see the medium damaged files. It's, you know, something slightly corrupted. You can, of course, you can, you know, you have these little tiny bit errors, and this is quite interesting category of files. It's just slightly, you know, very slightly corrupted files, and those are very interesting to actually. Now you can actually understand with new feature what's the problem of file is. But I'm going to show it a bit later. And so for most of the files, we can also show EXIF, but those files. Okay, so here you have the EXIF now. Basically, yeah, so you see this Photoshop. You can see the camera model here. So if you're looking for particular cameras, but you know, you can also do it in you know, Windows Explorer. You can also see the camera model and, you know, capture data and so on. But that's really handy and useful just when you look into something. If you know, like, your customer sometimes or the client wants just, you know, shots from particular file, particular camera, or you're looking for pictures from particular camera, you can just quickly, you know, see if those files are there or not, right? So yeah, here we also have, as you can see, documents, doc files, and if you open any of those, it's going to be just, you know, just normal file, working file, because as you can see, those are in the good category. So after quick search, we haven't found any, you know, corrupted files here, because that's pretty good dump. If you look at the you know, ECC map, it's kind of, it's already corrected, I believe, but not all of the pages. So here, one of the really nice things we have added is this ECC map. So basically now you can see what's wrong with your file, what's wrong with your particular file. You can understand now whether it's actually, you know, like, it has bit errors which are caused by the, you know, problems with memory chip, or it's some sort of real, you know, real corruption, or, you know, some fragmentation of file, or whatever it is. So yeah, and we can also let me just show you like example of how you can also use this basically the features of File Carver. Let me just corrupt the case, or corrupt all the pictures. Let's say we forgot to apply pair. So that means just a lot of pages we have now, well, pretty much all pages are mixed up, right? So they're not in the proper sequence. So let's run File Carver again. Right. First of all, you can spot here there's no good files, obviously. So they are medium corrupted, critical corrupted, or some sort of, you know, tiny bit error corruption, but that's mostly like a very small files. Yeah, so you can see that's very interesting, by the way. You can actually see here quite quite heavily corrupted file, right? But the question is, what's wrong with it? Because we got at least multiple causes of the problem. It could be either bit error, or it could be, some problem in your wrong XORed key, or slightly corrupted XORed key, or maybe you forgot, like now I did, we forgot to attach one of the transformation element here in the workspace. So yeah, but how to make sure that this particular file, say, has no bit errors? Right now, you can actually click, select the file, and open the map of the particular file. You can, of course, you can do, you can select multiple files, and open the map of multiple files here as well. It'll show you ranges. So here's the interesting thing, right? The file is corrupted, but you open up the map of file, and it's just all right. The file looks just, perfectly green, perfectly fine. So does it make any sense now to run, to start rereading this file? No, it doesn't, obviously, because there's nothing to reread really. It's all green and nice, right? So now you can certainly say that rereading won't fix the problem. So your problem is not in bit error. So here you can open another one. Like, it's pretty tiny files, but still. See, that definitely looks to me, and I hope to you as well, it definitely looks like a bit error, right? Because that's how bit errors look like in most of the cases on JPEG files. Right, so yeah, you see it's green, so you can say for sure this is not bit error problem. So it's something else, and this something else is here, right? It's some, well, I mean, now obviously I just removed pair, but in a real life scenario, it could be wrong key, XORed key, or slightly wrong XORed key, or if you did extraction of XORed key yourself, okay, well, not really. If it's slightly corrupted XORed key, then you will have bit error. So it's yeah. So basically, it's usually like now I just completely forgot to apply pair element, which basically removes the multi-plane allocation, transform it to single plane allocation, right? So that's how you can understand that the file is not corrupted by bit error. Just open its map, see it's all green and good, so there's nothing to read really. Of course, this is just one of the usages, and I would say there's probably like alternative usages or like additional usage of this ECC map. But of course, the main usage, as you can imagine, the main usage of this function would be to actually significantly improve, save a huge amount of time when you're doing data recovery, right? So basically, if you in many scenarios, as I know, in my experience and experience of our users, our support department, we know that sometimes people looking just for specific things. Right? They're looking for specific pictures, looking for, and sometimes people just looking for like 5 specific pictures. It's not 5,000 or 500 pictures, but just 5, or maybe 10 pictures, and so you don't really need to, and sometimes you even you just want to do some sort of estimation of case really quick, or you need to urgently get some particular files. So you don't have to reread the whole chip, because sometimes reread, well, you can imagine like a 128 gigabyte device, and you're going to read all blocks. Well, I can tell you, normally it would probably take at least half day or maybe 1 day, depending on your performance of computer and so on. So this particular feature, if you know what you're looking for, of course you can, if you get file system, you can also analyze, you can also read the files by through file system map, which is probably a better option. But sometimes you don't have file system, and that's definitely feature to go, because from here you can select particular files, particular pictures which you want to fix, and just reread or maybe reread a specific category, particular category of the of found files. Right? So that's pretty much how it works, and yeah, now it became much easier, simpler interface, more like user-friendly interface, plus a very useful option for ECC map, reviewing files, carved files through ECC map. Right, so yeah, we got a good question here regarding video files. We're now working with these several containers as well as several codecs, mostly this H.264 codec. So I hope we'll in some time. I couldn't really say now how long it'll take, but we'll do something. We'll have something for video files as well. Yeah, the thing is, it's always like always when we add new category into File Carver, we want to add it with integrity check, right? Because you want to make sure that file is valid or it's not valid, and in many cases we're trying to figure out how bad or how how good or how bad the file is. So you can some files, they just don't make sense to reread and to spend time on this, because if you're doing carving, you getting also deleted files, and deleted file or partly overwritten files, they can be really useless, because just the whole file is not existing, but only several sectors or clusters or whatever. And yeah, so we always want to make sure we can check the how good or how bad the file is. And in all of the most of the categories we support now in Carver, comparing to other software, let's say what kind of make this Carver better for flash memory probably is we can say for sure first of all what the problem is, and we can tell how vastly file is damaged. Let's say JPEG file split into 4 categories, Office files split into 3 categories as well. All right, so that's pretty much all about these features we added into the visual learning constructor. But there's just one remains, which is quite a big one, and time-saving one, which is sort of like the new toolkit for. I hope you can see the screen. So yeah, in the visual learning constructor 3.9, we have added quite a powerful tool or toolkit for for dealing with the bad columns, because as you may know, I guess, majority of the newest chips, they do have bad columns. And especially I'm talking about TLC chips and QLC chips and so on. They certainly have. Bad column is basically, you can find the article on our website, in our knowledge base. We do have explanation of bad columns, graphical explanation and so on. So I would certainly recommend it to go there and read it, and you will see the cause of bad columns, why they occur. But obviously, most of the reason is, flash chips are in some way they are very similar to hard drives. And, hard drives, they are not ideal as well. So on every disk out of factory, you have defects. And so bad columns are similar defects, such as track defects, but they just called bad columns, right? So it's most of the time it's a vertical, vertical byte or 2 bytes sometimes. Which go through all the plane. So basically, it's some sort of like weak places of flash memory chips. And so, because nowadays the technological process of memory chip manufacturing is so, it's so small now. The memory chips they made now, I don't remember exactly, like 16 or something nanometers now, the technological process, 16 or 17, and that's pretty, it's pretty small. And on such a scale, you cannot really control, control well the quality of silicon, the quality of the materials that are used for memory chip manufacturing, for lithography. And so, because of that, you're getting sort of like memory chips with the weak places. And of course, you as a user, anyone as a user of flash memory, nobody wants to get flash drive with defects. So nobody wants to buy a flash drive which doesn't work, right? And so manufacturers decided, okay, let's do an interesting thing. Let's do a trick. So let's just analyze the quality of chip using some specific statistical analysis methods, which we, by the way, also use now for bit column identification. So they basically analyze the chip byte by byte, like column by column, and they figure out which places are the weakest ones. So where they get more bit errors than in neighbor columns. And so by that sort of like a self-test of the memory or factory test of the memory chip, they do create some sort of table, let's say table of bit columns. Sometimes they store it in flash memory, like SanDisk, for example, do. But also when memory chip is supplied to final manufacturer, when controller is connected basically to the board and to the flash memory, controller manufacturers, they also do some sort of testing or self-test of the memory chip. So they will also add their own bit columns. And as a result, when you're dealing with the cheapo, when you get in device out of user or out of customer, you have like a bunch of bit columns sometimes, and there's no really like a special command that can pull out like all of them out of memory. There are some special commands that can help to extract part of bit columns, but not all of them, unfortunately. Right. So, and since the several and if you already dealt with bit columns, I do believe you probably saw how they look, right? In many cases, they look quite specifically. You can spot some sort of, whitish pattern. In some cases, you can spot darkish pattern. In other cases, like Elcor Micro, which is AU controllers, you can see pretty much nothing because bit columns are XORed, right? So on the top of bit column, they apply XOR. That's pretty, sometimes could be really frustrating to find them all. And one of the, but as you know, if you use Visual Line Reconstructor, you know for sure that we have tool now. It's pretty good, actually, in my opinion. Well, I mean, comparing to other solutions or comparing to, removing them from hex or somehow manually, what we have now, it's not bad. You go through bitmap, you just hit the columns manually, but it's the problem is it's time consuming, right? And our goal is not only to as a vendor of the software and hardware, not only to support something, just support something, but also to support it efficient way, let's say optimized. It shouldn't take so much time. And for me personally, and pretty much for any engineer here in our company, it's really frustrating dealing with those bad columns. And this is one of the you cannot start data recovery until you remove those damn bad columns, and that's pretty bad. Sort of like what really made us develop this tool as soon as we did, actually, it took like 1.5 months or so, is first of all, we got some documentation about the memory, and we have seen that for some manufacturers, when they supply chips, they claim that 45 bit columns, or 45 to 50 bit columns, I don't remember exact number, for one plane, that's a good number. So they utilize this chip as a branded chip. It could be any brand, right? And then if this number exceeds the 45 or 50, this chip becomes sort of like defective or doesn't pass quality control, and then it's getting sold to third-party small companies, and then they basically sell it or make devices with no-name chips. So this chip becomes basically no-name until we read ID, of course, right? And in such chips, we get in like chips with 100 bit columns, right? Sometimes my probably Guinness record was I recently got a case where it was probably 300 or 400 or something bit columns for one plane. So that was really end of idea of trying to remove them manually. This is just a nightmare to remove, you know, hundreds of bed columns. You can spend like several hours. Right, and so then we decided to, okay, so we have now in Visual Learning Constructor, since the last update, we have added quite a very powerful platform, very, you know, flexible, adjustable platform for statistical analysis of the dump. We can do pretty much, you know, statistical analysis of anything we want now, blocks, dump, pages, particular columns, pretty much anything. And this helped a lot for bed column automatization. Yeah. Basically, the tool we made, which I'm going to show you now, in 5 minutes, it's basically it's automatic tool, and for many cases you will get just clean result within just, I would say, 10 seconds, 15 seconds, 30 seconds, whatever. However, it doesn't work, in 100% ideally, and you still have a very powerful tool set for adjustment, or for semi-manual, or let's say for purification of result, right? It's not that you have to go, click and go to the end of page through bitmap as we did before, but now you can just simply group all bed columns together on the top, just quickly go through them within, say, 30 seconds, and understand which one to remove and which one to keep. Because sometimes, spare area may look like bed column, but you shouldn't get confused, because bed columns normally are statical lines, static vertical lines, when spare area does change in most of the cases. So, and as you can see here, it takes like 2 steps. First of all, we do statistical analysis of bytes, of every single byte in the page, and then on the second step, and we do like a soft decision. Basically, we just show you which bytes are most likely bed columns, and then you have to decide as a end user. You have to decide, or apply, or maybe check if you want some, or apply some particular filters in order to apply those bed columns, right? So let's go. Let's jump into the software. I don't want to look boring. Now let's open up one of the cases, and those cases you guys have in Google Drive. So with the link which you got with email, you can download, by the way, the PDF file, and as well as those cases. Those are not the real size cases, but we just pulled out like 20 or 30 blocks out of every case, and that's where we conduct bed column analysis. Let me open up the case. So I'm going to open now case number from bed column folder. It's going to be case number 1. Case number 1, which is this particular one is a Phison controller, but it doesn't really matter which controller is used. So this analysis is not exactly based on controller. Well, I mean, you can actually select preset defined for controller, or you can just use universal preset, which will work no matter what controller it is. All right, so I hope you can see the screen now. You can also, as I said, you can also open the case. It's going to be case number 001, or, well, yeah, 001 Phison, or PS. It doesn't really matter which particular model it is. What we did, during the past sort of like months and a half, after previous update, we analyzed a bunch of devices. We analyzed quite a huge amount of dumps, and we tried to group group solutions, or automated solutions for bed columns, divided by controller brand, and that's most in most cases it actually worked. So we created a special sort of like a plugins or filters for particular brands. So let's see how it works, right? So first of all, if you open a case, or you can look at the screen, I already have here a physical image, BCR element, ECC element, right? So here, the bed columns were already removed, and as you know, we kind of actually beginning now from the end, just so you understand how to check yourself, right? So in order to check if you removed bed columns properly or not, or if you removed all of them or not, you have to find ECC. You have to find ECC, and in, of course, huge majority of cases you can do. And so then once you find ECC and you look at the map, right, and if it looks green, that's all. Then you got it right. You got all bed columns removed. Well, I'll have another dumps. It's not going to be as green as this one, but that's just multiple times reread dump, and it's a purified dump here. So, anyways, that's it can be light green, it can be dark green. Doesn't matter much, right? So now let's go sort of like reversal way. Let's go back. So before ECC, we got this BCR, right? So first of all, let me show you interface. We actually try to keep it like it's really simple and not to create something like completely new window, completely new interface, just to confuse people more. But we rather try to keep things simple and just kind of like adjust what we already have, so you can efficiently use it, and you don't need to learn from scratch how to use it. Yeah, so here nothing really changed. You still have to specify page size. Still have to specify, well, it's a sort of like predefined automatically actually, but the only thing you have to make sure you properly define is physical block size, because it's not always matching to what you have in memory chip configuration. I do believe Igor probably showed some of this on previous webinars, which you can find on our YouTube channel. And I think Igor will send the link later to YouTube channel. Make sure you subscribe if you didn't yet. So yeah, that's the only thing you have to control. Just keep in mind. We also have, as far as I remember, in knowledge base, some article that does explain what is a virtual block and what is physical block. All right. So let's click on the edit here, and there you go. You can see still quite a interface that you have seen before, as for those who already use this feature. And that's what we've been doing all the time, right? For most of you, I do believe it will look very familiar now, because you had to, go to the very beginning of the page, right? Press Shift, and then scroll it all the way, step by step, till the end of page, which is truly frustrating. I can understand it. And then you had to, well, with the Control button, right, you can deselect bed column, and with the Shift, you can select it, right? And so that's how it looked. Right? Then you can just remove it if you did it wrong. But yeah, that's like you have to go from the very beginning. You cannot miss any bed column, otherwise nothing is going to work. You have to remove them all. And so you had to really spend a bit of time, sometimes quite a lot, especially if it's 100 or imagine 200 bed columns. That's a nightmare. Yeah, so you had to go to the end of page just to see if there's nothing left that looks like bed column. Right? And then it's not the end, because you had to actually switch the plane, because you have to make sure you remove bed column from all the planes, right? And then, well, obviously, as I think most of you know, the bed columns are not really same in planes. So, and they actually always different, right? So, and Igor is saying now here in chat that it was very convenient. Old mode, it was very convenient as well, but we just did it better. Well, in my opinion, this one it was okay, but now it's really good. So, anyways, let me just remove all what we have here from both planes. And then we'll try to, well, create it now faster way. Right? So now, let's say we don't have ECC. That's how your, basically, you got physical image, you connect BCR, MC1, right? And you had set up your parameters here, which is a block size. Just, make sure you control block size. Then you hit on the edit button here, and basically, because it's a bit a new interface, and we are making now article. Yeah, it takes just 2 steps to remember how to use it. Right? So first of all, we have to select preset. Luckily, we made presets, special presets for statistical analysis of dump for different devices, for different brands. Right now, we keep it in files for a while until we move it to database. So here, what we have for now, those presets are working quite well. They're quite adjusted, but let's say if you get any case yourself where it didn't work so well, you let us know to support department, and we will fix it. We will adjust it, and we will see. So for now, I can go for universal. If I don't know controller, I can just go for universal template. But let's do it step by step, right? Let's try at first something that we more or less know. Right, so that's a Phison controller. I'm going to choose Phison preset. When you're done, you click read values. So basically, it's 2 buttons you have to use. Select preset and then read values. So when you read values, that's where statistical analysis happens, and it does happen quite fast, as you can see. Right, so, but here's one important thing. For analysis, for statistical analysis, for now, we use only one block, so one particular block. So you have to make sure that you selected not empty block, right? You have to scroll down. Well, I apologize, in this particular dump, I don't have empty blocks because it's like just a chunk of dump, right? But in the real case scenario, you have to find the block at first, right? You have to scroll down, find the block, and then you just need to click somewhere, right? You click on the block in the bitmap, and you have here current block 4. But your statistics now is calculated for block number 0, if you remember. So when you click, just need to refresh values, read values, right? And now you adjusted, actually, you found the block with data, you adjusted it, and also you adjusted statistics. It didn't change here, but if you run this on completely empty block, it's not going to work, obviously, because you need data to be analyzed. Yeah, basically here, when we read values, we read the columns, right? So we read basically we read the block as a columns, right? And then we analyze every single column, what's inside this column. Right? Of course, if you did manual bed column removal yourself before, you can probably remember how bed columns look like. But if you didn't, let me quickly show you. When you scroll down all the way, well, actually, let's go back to a physical image for a second. Right? So when you go through bitmap, through the page, that's what you see. Right? You see the shifted. You see, apologize. You see the shifted spare areas, and then you see those, inclusions. Unwanted inclusions, and those inclusions are exactly bad columns, right? So this is what we have to skip. This is what controller did skip, and that's what we want to, cut off the image and just get the data. So yeah, now I'm on block number 0 here. It's got a data. So I can use this one. So I need just to sort of like synchronize. I need to update statistics here. So now my current block is 0. So make sure when I run this feature first time, make sure to find block with data first, right? Then click, just simply click somewhere. Click on the data, and then read values. But first you load preset, obviously. So load preset, click on the block, read values. That's all. And then what you got here is very interesting. And that's a new thing we added to this particular tool, right? It looks very little, but it's been a lot of work actually done to simplify and to automate it. but it all works in the background, so you're not overloaded with a bunch of information. All right, so what we did here is, so what's the idea here? So the main idea here is to point you to most possible, or to the bytes that are most likely look like bad columns. So selected items here are most probable bad columns. But you have to check them. But it takes now seconds, not even minutes, to to check them all. So what we did when you applied when you got statistics and applied preset and calculated statistics, or read values, what we did is we detected all bytes that look like data bytes, and we said, okay, you don't need that. Let's unmark those and move them down, right? So you don't really get overloaded with a bunch of lines and rows and so on, right? So number of rows here, as you can imagine, equals to the page size. So the page size here is well, that's actually, see, there's 9 blah blah. It's not the last byte actually. Sorry. So the page size is 9216 here. So the last byte is obviously going to be 9215, which has been moved to the top. So here it is, right? So every line here represents one column. So in bitmap, it's column, right? In here, it is a horizontal line, or 1 byte line. And so from this version 3.9 and further, we decided that, yeah, I will explain what these FFs mean. Sorry. So basically, every line here is 1 byte, right? So all the bytes that looking like data, we just moved down. You don't need those, right? You don't need to look at those. And from this version, and I think forever more or less, we decided to analyze the bad column size is going to be 1 byte now, always by default, because we analyze by binary statistics of bytes, not double bytes, because many of you probably know that in many cases bad column actually is double, the size is double byte, word, or 2 bytes as you wish. And in this exact case, it is also 2 bytes, but we cannot analyze pairs of bytes because they may be shifted on the odd number of bytes from the beginning. So they not really stick well into pairs. So now this is what you're left with, basically. When you apply it preset, you read the values, and you're left with possible bad columns here. And for now, the first step was done, right? So that's just the first step. Right? Apply preset, move up all the bytes that look like bad column. So here you can see the flag. The flag means this. If you click right button, so there's some settings here. If you click right button, you can actually, you have a set of different operations and so on. Yeah, I see the question in chat. FF, what FF means? I will show you. I will show you what it is. Sorry. All right. So now, as most probable places for bad columns, you can actually. I would recommend it to always just have a quick look and understand how bad columns look in your case, right? Because in some cases, bad column looks like whitish pattern, like this one. You see, it's a whitish pattern, And as you can spot, it's double byte pattern, right? So you can tell for sure, well, most likely, in this case, most of your byte columns, or maybe all of your byte columns, they're gonna look like, 2-byte whitish things, or whitish verticals, right? And they could be actually different. As you see, the values here, they're different actually, right? So some of them may have this, strange things here going on, and some others, they could be very static, very, straight vertical lines. But that shouldn't really bother you. You just need to understand in overall how byte column looks in particular case. Because in other cases, it's very easy. For instance, it could be just a single FF, right? Or single byte, FF byte, which is byte column. Or it could be double FF actually, right? So just to have a quick look, try to find how it looks, right? So now I know here, it looks like something white and something vertical, right? So I can quickly go now through the navigation. So you can navigate with mouse, or obviously you can just navigate with your keyboard arrows, right? And it's all synchronized by default, so you don't have to double click or hit any buttons to synchronize. It's just, you just keep keep clicking, keep going down, and you can see yourself how this stuff looks like. All right, so this is just the first step we've done. Now, second step, I would call it post-processing, or adjustment, or purification of results, probably. So for now, the problem is, as you see, spare area also looks like columns, right? It's also vertical. It does change from time to time, but byte column can also change from time to time, right? So what do we do? I mean, if you just click here, add all byte columns, that's what we're gonna do in a bit, not so distant future, in 5 minutes. So you can add column one by one, right? But certainly it's not efficient, as you can imagine, because you normally want to add them all. So if you add them all, well, what happens is you're gonna actually add SA as byte columns as well, and that's pretty bad, because if you remove spare area, you got two problems. The first problem is ECC is not going to work at all, and the second problem is you remove spare area, so you cannot really assemble logical image properly. So we don't want to remove spare areas, but luckily for the second step, we made here like a post-processing, or like filters, right? You have special filters here. So let's just remove this stuff. Right-click on you can right-click on any byte column if you're doing the case with me. Click, okay, so first of all, these all filters will clean up, will clear selection. Right? So this is all potential byte columns, but now we have to remove a couple of things from these potential byte columns. All right, so you can do clear use by type. So you can say, okay, I want to clear all FF. So FF is one, type of byte. So you can do that. So you can clear, clear by type, and all FFs are going to be removed. But let me just, okay, then you can set by type. You can, put it back, put flags back. Set use by type. All right, FFs. You can, clear all of the bytes for some reason. Or you can set all of them, again, for some reason. You can add some current byte as byte column, just one byte, or you can add all selected bytes as byte columns, right? So this is what means be selected. And here is one menu which has another level of menu. I think in a probably next update, or maybe we'll see, we'll probably add most frequently used buttons on the top menu on the panel, because there's plenty of space, as you see. But for now, we just really need to work with this feature for months to months, and understand what is most frequent feature to use, and then we put them up. Filters. All right, so this is one of the really interesting part of the whole thing. So let me share you this document again, and I would recommend you to keep this one open while you're watching this webinar, because that's quite important. All right, so we have several filters here. Some of them will exclude false positive bad columns, right? We call, false positive bad column a scenario when you have something else selected as bad columns. That's going to be false positive, right? And include missed bad columns. So this will, set flag on for the bytes that for some reason were missed, and they are real bad columns. Right, so two types of filters, basically, set flag and remove flag, according to some rule. And one of the rules here is, which is probably going to be most frequently used, clear use for chains. Well, here's the thing about bad columns. They never come in chains usually. Well, sometimes they do, like you can have 2 byte and then another 2 byte bad column, but that's more like exception. In most of the cases, bad column is just isolated, isolated line, and on the left or your right, probably on the right, you have data bytes, right? So this is exactly what you can see in the case I'm going to show you now when we get back to it. Right? So clear for chains. You can see explanation here. The explanation of the filters. It will this one will remove selection from more than 2 sequential non-data bytes, which begins or ends on FF. So that's what we call a chain. You can also remove just a single FFs if you like to, or if you need to, or you can include the opposite action. You can include additional byte as bad column. In many cases, we can find precisely, first or second byte of bad column, but we couldn't, precisely find the second one. And so this feature, set use for additional byte, it will expand selection, right? It will include second byte as bad column if it's not, if it's surrounded by data, right? Could be FF or anything else. And the last filter is to select XORed bad columns, because that's a hard subject, but in this particular version of software, it does work quite well. Not on all cases, however, but we'll get to it soon. So, all right, let's get back to the case. So now we have these filters here. So let's see. First of all, let's start. Obviously, you always start from the top. Bad column, the first one, 2 bytes, right? 848, 849. So how do you guys think? Is it a real bad column or not? 2 bytes. Just drop message to chat. What do you think? Real or not? Yeah, well, not. Well, well, actually it is. Yeah, it's you see, it's a 2 isolated bytes, which are surrounded by data, right? So this is data. I mean, even though it's XORed data or whatever that it is data, right? Data has high density, and this doesn't have high density of ones. So this is a real bad column. So this one we want to keep. So let's go to another one. So this one looks pretty much similar to previous one. So it is also bad column. That's a real bad column. So this is how bad columns look in this case. They look like a double byte, whitish, double byte, darkish vertical lines over the white space. So that's how it looks. All right, let's go further to another bad column and down to the some FFs. So this is also a bad column. Right, this one as well. There's a first byte of bad column and there's a second byte of bad column. And so here we got an interesting place. We spotted an interesting place here, which is actually, well, something. Yeah. So how do you think? Is it actually a bad column or not? What do you think? So, if you guys can drop the chat. Yes, no. Is it a bad column or not? Not. Huh. You nailed it, Alan. It's not. Yeah, Kevin, that's right. It's not. Why it's not, actually? Why not? I mean, it looks to me like a vertical line. Well, so why not? Any ideas? So basically, because first of all, for those of you who have some experience with the chip of recovery or with the visual non-reconstructor, you can probably recall the typical structures of pages, and this is certainly looks like Phison like page structure, right? So it's got like 8 bytes of SA, and there's something that changes from block to block. You see, so these particular bytes, they will be SA. And then they're surrounded by FFs, which is another sign of being per area. And this one was selected here as bad column. Well, why? Just simply because this is a vertical line. They also vertical. So that's the particular preset for Phison looks for something that looks like that. and yeah. So by mistake, or not really by mistake, because we did just one step, and now we have to do the second one. It was detected as bad column. And also, if you scroll down all the way to the end, you're going to get a bunch of FFs at the end. Well, they also selected like, well, not bad column, but FFs. Right? So do we need those FFs? Do we need to add those as bad column? Surely not, because this is not bad column. This is just, FFs. So, but can we actually use this, clear, FF filter? Well, we cannot, because this is not single FFs. By single FFs, we mean just one FF surrounded by data bytes. So this is not surrounded by data bytes, obviously. So it is rather chain, we can say. So this thing is chain, right? It's more than 2 bytes of same stuff, which is no data, no bad column. So here we can actually apply filter clear chains, right? Clear use flag for chains. Click, and now you got this per area deselected, right? Now we have those bytes. Those are real bad columns. Those are 2, right? And then we got seconds per area actually, and it's got deselected quite precisely. And then we got 2 other bytes that are actual bad column. And so you can see this is bad column, bad column. All right, looks like we got them all. You can just, just for keeping things organized, you can click on the header of the field here just to sort them one by one, but by selection filter. And now you can just, last time you can just go through all of them just to see, to make sure there's no SA selected or anything else. All right, so clean chain filter will probably use most of the time, will be used most of the time, and this will remove, anything else surrounded by, well, basically remove anything surrounded by FFs, more than 2. All right, so yeah, okay, that's I think it's pretty much this particular case is more or less clear. And well, now what? We selected them all, and those are all supposedly bad columns. So now we just simply click on one of those add all bed columns. Hit all, add all bed columns. Now we got them here. Now we can go back to the workspace and check ECC map. All right, it looks green, right? But not all of it, of course, because as you may guess, we have removed bed columns just from one plane, right? And then there's another one. So, but I will leave you I will leave second plane for you guys to check yourself to find all bed columns, and you know, eventually you will have to get perfectly green ECC map for, you know, every single block. So that's, guys, a homework for you for this particular case and for others too. So I'm going to show you several more cases, and I'll show you how to remove bed columns from one plane, and you can try yourself for the second plane. As you can see, this automatic tool is quite automated, but still, you know, you have to. It does analyze every single byte and you know, binary statistics of every byte. But you sort of, you know, have to control this artificial intelligence in order to, you know, not to let it decide everything for you, because it may not really work, you know, from the first step. And obviously it doesn't. Like here, it just won't work if you just, you know, select preset, read values, add all bed columns. It's just not going to work. So you have to apply a little bit of, you know, you have to adjust it a little bit. So the second, you know, step, which is filters, that's what you have to take care of. But as you can see, I mean, as you can see, it's pretty fast now. So this is how it will look to me, or, you know, to any user who has more or less experience in the real life. So let me just remove them all. So for this particular case, I mean, sometimes case is harder, so it takes a bit more time to analyze. But now we have no bed columns. Select Phison preset, right? Read values. All right, just a quick check. All right, we have chains here, certainly, you know, remove chain. Just in case, I would probably, sometimes not, sometimes yes, I would check, you know, check bed columns real quick. Yeah, so I mean, it takes, as you see, for such case, like, you know, for one plane, right? It's like, you know, 15 seconds, 20 seconds, whatever. And then, of course, you don't have to every time, you know, check it manually, just maybe faster to check the bitmap or ECC map, sorry, and make sure all bed columns removed. So that's, yeah, that's a, as Alan said, yeah, it's a big time saver for sure, right? So I think we're done with this particular case, and you guys try yourself second plane. That one is going to be quite interesting. So that's your homework. Let's move on to the next case. Again, just for demonstration purposes, we got here BCR as well as ECC. Yeah, as you see here, there's nothing was done to initial dump. So we got some bit errors here, and which will be in most of the cases successfully corrected with you know, multiple reread with a retry. So let me just you know, connect another BCR element just to show you, you know, everything from scratch. Right? I need to adjust this one to the physical block block size, and actually, let me show you real quick how to find your physical block size. Basically, physical block size equals to height of bed column. Right? Height of bed column is really easy to measure using bitmap functions. So click on the very first you know, page of bed column, and then click on the last one. it's a 258. So physical block equals to height of bed column, right? It's a 258 pages here. And because your page size is essentially 90:16 in this particular case, so you can do quick math. 90:16 times 258 is going to be, let me just quickly calculate it. It's going to be this. And here's another one, another parameter, which sometimes you have to adjust, just like in this case, number of planes, right? So the question is how to understand how many planes you have. That's fairly easy if you have bed columns. You simply need to understand how many, like, differently structured blocks you have. Or how many, different offsets of bed columns you have. Look at this one. So this is one bed column, right? You scroll down and you don't see this bed column anywhere here. So that's another plane, because every plane has unique bed columns. And then you scroll up. So at least it's two planes, right? Then you scroll up. And wow, you see another bed column here, but it's like shifted, not like previous two. So at least we have three. And there's no three in the digital, digital electronics. At least it has to be 2 or 4. So usually it's power of 2. So at least we have now 4 planes, right? And that's fairly easy to check. Until you start to see repetitions of these structures, you can very easily understand how many planes you have. Right, in this case, it's going to be 4. So I will certainly adjust this one to 4 planes. And that's your parameters. They match now to what I had before. And now we click this edit button here. And we got a fresh BCR, bed column remover. Now we select preset. It's going to be Silicon Motion now, because we know it is the same controller. Open. With values. And this one is interesting. You see, we automatically remove data bytes from bed columns. And now you're left with, well, a bunch of FFs, which are at the end, right? So from here, we certainly know that we should actually, remove chains here. Clean chains. And as you can spot, not only FFs were actually cleaned, but also something else, which has no type. So for now, as you see, we didn't assign the type to spare area, because that's spare area here, and it doesn't look like bed column, neither as FF. So for this particular controller, for this particular preset, we don't define spare area, and so we can easily exclude it from analysis. And as you know, Silicon Motion controllers, they do have spare area at the end of page, usually, right? So, and then the rest is just a few bytes remain, really. You can see quite clearly, I think, this is also, something strange, some sort of inclusion. And that's certainly a bed column. You can compare it to another one. This one looks differently, but still, it kind of has the same density and so on. So this one is also a bed column. But what is this FF? That's unanswered question here. Could it be bed column? Well, technically yes, but most likely not. And in the majority of cases, it wouldn't be. You can kind of notice here, it does repeat every something like 1,000 bytes or something. which simply means this is, you know, end of something, right? And in case of silicon motion controllers and many other controllers as well, this would be end of ECC. So as those of you guys who kind of experienced, you may spot yourself sometimes, end of ECC has, you know, FF byte. So that's quite typical for silicon motion. It's kind of typical for some of the Phison controllers and some, you know, other controllers. I have never seen it in SanDisk or some, you know, some XORed micro don't use it usually. So yeah, most of the time it would be silicon motion if you see this vertical line. So you can see here, but anyways, it's a kind of like a sign for you that usually bed columns look, you know, uniformly. I mean, they look similar everywhere, all over the place, all over the page, right? So this one would be bed column, FF. Well, it's not really bed column. So those are certainly bed columns. Again, FF. So we don't need to add this FF as bed column because it is not bed column, right? So and most of the time bed column is double byte actually, and we can clearly see this is double byte for sure, and then there's some weird stuff here inside, and you know, some of them even completely blank, you know, white. And that's okay. So we want to keep this, you know, we want to remove this white, you know, white lines, but we want to get and we want to keep these dark areas, right? Dark verticals, because this belongs to you know, ECC. If you remove it, technically ECC will still work. So I mean, if you remove those FFs, it should be fine as well. But let's don't do that. So I can simply apply now the. I mean, it's not so many as you see. You can just you know, uncheck it manually, for instance. But I wouldn't recommend it to do so because it, you know, it develops bad habit. Because next case you have 100, 150 bed columns, and you know, you don't want to go through all of them and, you know, manually deselect it, right? So right click, filter, clear flag for single FF. That's what you use. And those FFs are automatically, well, sort of like automatically removed. Now you just, you know, for you know, checking yourself, sort it by selection, go through it, and you can see it looks all right now. So now right click, add all bed columns, they're all here now. Right, and then you can connect ECC, clear the map just in case, open the map, and you get your first block green, right? And then obviously others are not as green as the first one because those blocks belong to 3 other planes. And so again, here, applying a very similar logics, you can, as your homework, you can try yourself to remove the rest of bed columns for plane number 1, number 2, and number 3. So that's up to you guys. And I would certainly recommend it to try it. All right, so that's pretty much all for silicon motion. Let me open another case. That's a really interesting one. We got 2 more cases. It's not going to take you know, long time, I promise. Probably 15 more minutes, and we get a Q&A, quick Q&A session. Now let me open the case number 3, which is Elcore micro XORed bed columns. That's really interesting one. So here we have now all bytes detected as data, yeah, because they all XORed. So what do we do here? So here we have the filter set use for XORed bed columns. Right? So in many cases, bed columns, XORed bed columns, it's like 2 bytes basically, or sometimes 3 bytes even. And those 2 bytes or 3 bytes, they have very similar statistics. They look very, you know, similarly. And using that particular property, we can actually find just, you know, pairs of bytes or triplets of bytes sometimes that look kind of, you know, similarly. Now you can just organize them by, you know, sort them by selection flag. So that's kind of important, you know, thing here. You can sort them by pretty much anything, by type, by byte, and most of the time you're going to use this. You know, if you want to basically move them up, just click sort by flag, and you get this here. And so here, that's how XORed bit columns look like. For those of you who are familiar, probably, you know, you'll see something that you're familiar with. And for those who are not very much familiar, that's basically how XORed bit columns look like. They look like 2, or in this scenario 3, you know, very similar, but not always the same, by the way, so don't get confused. It's not like 50, 50, 50. Well, sometimes it could be, but in other cases, you know, a couple of bits or 1 bit can be flipped or changed. And so then the hex value is going to be different, but statistically they're very close to each other. So we can spot them automatically here and, you know, add them all as bit columns. And that's pretty much all. So now we can go back here and check it. I might need to clean them up. All right. And as you see, yeah, because I didn't delete bit columns from other planes, from another plane, it's still all green. Yeah, but as you can see, let's say if you remove those, so maybe got updated, and you can clearly see one of the planes is completely red, right? And then as you add those bit columns, you turn it into green, basically. Just need to refresh it. No, it's all right. Okay, so that's how it works for XORed bit columns. Not always, I have to say. We're still investigating these XORed bit columns for subject of, you know, full automatization. Sometimes it's more bytes selected than needed, so you have to go through them and you know, make sure it's not false positives or it is, right? But still, it makes the process, especially XORed bit columns, makes it like, I don't know, 3, 5, maybe sometimes 10 times faster than it was before, right? So yeah, here's one really important thing you have to keep in mind or make a note or just remember. For XORed bit columns, never run analysis on XOR, on block with XOR. So here, it's not going to work as good as it worked on plane number 0. So you try it yourself later. So because this is a block with XOR key, and statistically, neighbor bytes are very similar, actually, right? So for XORed bit columns, we do not use blocks. It's kind of, you know, like a paradox, because when we remove manually bit columns from XORed, you know, XORed bit columns, we do use, you know, it's better to use block with XOR because it's easier. When you use this automatic approach, you do not use block with XOR. So it's opposite, actually, right? So manual approach, you better to use a block with XOR. When you do automatic approach, avoid using a block with XOR. Luckily, majority of cases, it's very easy because majority of your blocks, you know, they do have scrambled data, not the key itself. So it's going to be very easy to find you block without XOR. Not in this case, though. So, anyways, that's what sort of filter you have to use for XORed bit columns. It's, you know, just a specific filter for XORed bit columns, right? So now let me show you a last case which I prepared. It's going to be non-name device. It's some sort of unknown case, unknown, you know, it could be anything, monolithic device, pretty much anything. And of course, if you have a known device, you better not to use, you know, specifically designed preset or plugin for a particular controller model. But you can use universal one. Right, let me share screen with you. All right, so hope you can see it. Let me resume. All right. Yep. Can you see it, guys, now? All right. Okay, so here we got again some, you know, unknown device. We have page structure that was easy to find. So here again, I have a, you know, solved more or less. This case is pretty bad. Will require a lot of reading. Probably I would go for 10 passes at least, depending on, you know, situation. So here we do already have, just to show you how much work it will take by hand, you can see here all bed columns that were already removed. And the number is pretty, well, high. It's a 283 bed columns. And this particular job, if you do it by hand, well, you can imagine it'll take a tremendous amount of time. I mean, you'll have to literally go through every single byte and, you know, you'll have to go through every single byte and, you know, remove it by hand, like every one of those, right till the end of page. However, as you can see, bed columns here look fairly simple. It's most of them are, you know, dark. Well, first of all, let me remove all of those with the Control A. You can select it all and remove it all, right? Yeah, it takes a bit of time sometimes when it's too many bed columns added here. So yeah, this is how, well, sometimes bed columns look like. So it's not always, as you can see, the algorithms that we develop actually took a bit of time. It's not, it's sort of like, it's got a little bit of flexibility. Let's say you can clearly see here is pure FS, but here it's not. But our presets will actually include this one also as a, you know, as potential bed column, because as I said, the algorithm is quite, well, I mean, it's not really any neural networks or artificial intelligence. It's not. It's a purely mathematical, you know, statistical analysis. And we got some sort of complicated rules, you know, what to include as bed column and what not. It's based actually on the entropy analysis as well as statistical analysis. So anyways, so how do we remove all of those, you know, bunch of bed columns? So I'm going to go for a universal preset. That's what you're going to use if you don't know which controller is. Universal one. So let's choose one of the blocks. Well, you can choose any one here. This, by the way, device has containing XORed key. As you see, it keeps repeating here. With values. And as you can see now, yeah, there's a lot of, you know, all of those pretty much bed columns were actually selected. And yeah, you can definitely go through them. It doesn't take too much time, you know, if you like to. In some places, you'll have even doubled bed columns here, like two together. And at the end of page, the strangely looking pattern, that's actually unused space actually in the page. But anyways, it was automatically detected and excluded from back column. So basically here, as you see, we have selected FFs, right? And if you actually sort now by type, it's not only FFs that actually got selected, but also some unknown types of bytes, which are definitely bad columns as well, as you can see. See this small dotted column. Also, it is bad column as well. Right, so in this case, we have like the whole bunch of bad columns. Most of them are dark. Well, actually, most of them are FFs, and some of them just darkish, verticals with some pattern inside. And that's very easy to spot using this automatic, bad column detection toolkit. Right. So for now, you can obviously, right-click, add all bad columns. And can you still hear me, guys? Got some message that my mic got disconnected. So, can you hear me? Okay. All right. So yeah. So now we got this whole bunch of bad columns added, and just to make sure, just to control yourself. The easiest way, as I said before, to make sure that you got all bad columns, fixed. Just open ECC map and check yourself. Yeah, as I said, this amount of bit errors here is quite quite high. But the main rule here is majority of pages. So this is sort of like a rule of majority. Majority of pages green. So bad columns removed properly, right? And then these red spots are bit errors here. It's not related to bad columns. So bit errors, bad columns is two separate things completely. All right. So yeah, you've got plane number 1 here, but unfortunately it's completely empty, so there's nothing to remove really. It's just a small chunk of dump, so yeah. So but this one is certainly interesting. As you see, it's around 300 columns, and I would definitely recommend it to try, try your hands on this one and on all cases we uploaded. We're gonna keep them in Google Drive for a while, so you can still get it downloaded and keep it for future testing. So I believe I've shown all the features we developed for the update 3.9. We're making now more interesting things which we'll add in upcoming updates. Thanks everyone. Thank you guys for joining our webinars, and yeah, we'll upload it certainly to the YouTube today, tomorrow. I hope we'll try to do it as fast as we can, but yeah, maybe tomorrow. Thanks for joining, and till next time. See you. Bye-bye.